You're listening to a Pop House Network podcast for developers by developers.
Welcome to Java Pop House episode 95. Hey, revisiting GraalVM. Hey everyone, my name is Freddie Gimi. I'm one of the co-hosts here at the Java Pop House. I'm a principal engineer at Expedia, Java champion, speaker, author, Seattle Java User Group co-organizer, and I'm here with my partner in crime, Bob.
Hey everybody, Bob Paul, an independent consultant, Apache Software Foundation member, Java champion, speaker, and Chicago Java User Group board chair.
Oh, and then we have to add now you're a PMC committer, right?
I'm not a PMC, so I did get invited to another community, the Apache Camel community, which is one I've followed and kind of contributed to for a bit now. Invited me to become a committer on their project. So always excited. One of the better run communities in the ASF. Lots of commits. Lots of very smart people, so excited to be a part of it.
So essentially, if anyone has a problem with Camel,
send it our way. I mean, they're a very active community, and they get a lot of JIRAs and things like that. So just send it our way.
That's awesome. All right, so before we dive in, wanted to thank our sponsor for the episode, Datadog. Today's show is sponsored by Datadog, a monitoring and analytics platform that integrates with over 400 technologies, including AWS services, Docker, and Kubernetes. Datadog's platforms bring together metrics, traces, and logs in one place, so you can get full visibility into your environment and improve your application performance. With machine learning-based alerts, customizable dashboards, and distributed tracing, Datadog makes it easy to unify disparate data sources so you can troubleshoot faster. Start your free Datadog trial today. Listeners of this podcast will receive a free t-shirt once you install the agent and create one dashboard. Visit javapophouse.com/Datadog to get started. And again, the URL is javapophouse.com/Datadog to get started. So yeah, definitely, we thank them for keeping the recording button on and feeding us beers, which is essentially fuel for these episodes.
Cheers.
And cheers. and yeah, give them a shot. They're really soup to nuts. They do everything on APM, including metrics collections, which is something that I integrated with recently, and that was fun. So yeah, we thank Datadog for that.
And you can get swag by visiting our site too. And it's starting to get t-shirt weather. If you can't tell, I've got my background to a spring background. So I'm getting, I may be getting ahead of myself for Chicagoland, but I'm starting to look forward to being outside and in good weather at some point.
Now it's funny because Bob is immune to or almost immune to winter. What we consider snow pants weather, he'll be okay, fine. I'm not gonna wear my shorts. I'm gonna wear long pants. And when I'm freezing, he's t-shirt weather. Yes.
Yeah. Sometimes those are just economic decisions. I was snowblowing actually a week ago in shorts. But the reason didn't have anything to do with my immune to the cold. It was a leg day, and I'd have to walk upstairs to put on pants, and that was going to be more painful than being.
It's the pain of cold or pain of going upstairs.
I'll suffer the cold more gladly than having to go up a stair.
Oh my gosh, I am such a I can't. Cold beats me. Growing tropical weather, but hey. All right, so today is going to be a box of chocolates, right? We have a tons of goodies cool stuff.
And with Graal, so we covered Graal before, and it was really just a flyover, really, of just some of the global things that you can do with it. A small amount of code. Today we're going to go into a lot more detail on what you can do with Graal, and we're specifically going to be targeting the native image options. So the thing about one of the more interesting things about Graal is being able to compile your Java code into binaries, and not just bytecode, and that where it'll run on a JVM, but actually a standalone binary that you can just take off of your PC and drop on another PC of the similar architecture and OS, and it'll just run without installing a JVM or anything else. And there's a number of other languages out there that are doing this. that have become very popular, like Go and Rust, which are taking advantage of just, some new compiling technologies to basically say, hey, this is my target platform, build me this executable. And then you go to their websites and they'll have, hey, depending on your architecture or OS, download this one, or this one. So it's interesting to see what's old is new again, because Java's whole thing is like, hey, you just download the jar and it works anywhere. We're getting back to OS specific binaries. And I think people are fine with that. I think there's a certain market on that in tooling or in small devices where, if I'm working on Raspberry Pi for a personal project, or I just want to give a tool to a team where it's, hey, I don't want to burden these non-technical folks with having to drop a JVM on and worry about software permissions or upgrades. Here's a binary that you just run and works. So that's kind of the use case that we're targeting for this.
And I know like it's interesting because for cloud platforms, we are really standardized, on particular flavors of Linux. And if you're doing containerization, like with Docker and stuff, it's almost like you have a dominant sort of like platform where you can really target your native image to. So
and that's right. And then you can take advantage of just some of the performance things, all the things I mentioned were more convenience things, but the idea that, hey, our startup times are almost instantaneous.
Yes.
Memory footprints tend to be lower on the native images, at the expense sometimes of disk, but I mean, disk is cheap. So folks generally don't worry about it. So I mean, what we're going to look to cover today is just the basics to get you started with some simple projects and building them into native images. And we're going to go through some of the options available within Graal to make different types of projects work. Because as far as they've come with Graal, they still haven't gotten to the point where you can just point it at most Java code and it just works. Usually there's some directives or things that you have to hint at Graal to make sure that it can do the right thing to get you all the way down to native with particular code bases. And some of that's just because, hey, it's Java. It's a very powerful language. There's a lot of features to it. And some of those features do make it extremely difficult without some hints to get down to those native binaries. The dynamism in the language tend to make that a little bit more difficult.
And I always like the interesting part is like Java, the JVM. One of the things that it can do that is always being like a challenge for statically, when you try to create a static image, was like this idea of dynamically loading classes, right? Like you can actually dynamically have a new class loader and suddenly load a new jar that was not there at the very beginning when you started the application. And these are the sort of like the interesting part is when you have sort of like a static image, usually you need to have completeness on what to expect from like how's your class hierarchy going to look like, what are the objects that you're using. So I know like a lot of like the things that Graal, what you need to hint it at is like saying, oh, these are things that are not on the critical path, but I might use, dynamic loading, which, it also encompasses this family of things like reflection. Where like you need to say like, oh, I might use reflection to actually load this particular class, and it's one of those where if you tell Graal that you're planning to do that in the future, it can say like, okay, I'm going to add it as part of my native image. So there's no real dynamicity to it. I already have it, but it's ready for you to actually execute it. All the code that you
add it, or even ignore it because you're not going to use it. So I mean, perfect segue into our very first example. So our very first example, and again, we're going to be doing some very simple code for this, but they're concepts that you're probably going to hit in any project. So it's not this one. Let's go find, here's our main method here. So this is a class, very simple class, right? So I have a static main method. Here, let me move our mug shots out of the way so people can see everything. Where I have a log attached to here. And this is SLF4J. And folks that know SLF4J know that it's one of those libraries that can bind to different logging implementations. So it's also a great haven for reflection and a lot of that dynamic class loading that Freddie and I were talking about earlier in the episode. And in a lot of these implementations, these are written to be generic. So you don't know which logging implementation you're going to use right up front. So you just write SLF for J and you say, okay, I'm going to have my runtime or some other thing configure it. But if I want this to run natively, that's something that we may have to work around. So right now I have a logging statement here and then just a print line. And on my class path, I shouldn't say on my class path, this is a Maven project. What I have in here in order to make this work, that folks that have worked with Maven are going to be familiar with, is I have my SLF for J API, which doesn't have an implementation. But I do also
interfaces.
Yep, it's just the interfaces. And below it, I have a provided scoped library for the simple implementation. So my implementation, if I were to run this code, would be provided by the simple jar, which is an SLF for J, and it'll basically just log out to my console for me. But the problem with it being provided means that this jar is not actually on the class path. I'm expecting this to be provided by a container or something else. So it's a very common scenario we run into with an application or even a library that we're trying to link to in Java. So if I were to try to compile this in Graal without knowing which implementation I'm using, Graal is going to struggle with that. But before we get into that, let's just explore this Maven file a little bit, just to go over a few things. I'm a big Maven user, and Maven has some really great plugins for even if you're just working with Graal by itself. So there is a Maven Graal plugin specifically for creating native images. And by putting an execution goal of native image and attaching it to the package phase, I can just run my regular Maven clean install, and it is going to produce that native image for me without having to add any new commands.
Really? No magic about like having your own GraalVM downloaded? And
yeah, okay. So you do have that. You do have to actually. So if you're going to build, a requirement is you do have to have Graal installed, and if you're using Maven and you're pointing, you're using the Graal JVM because it is just a JVM with some enhancements. If you're using that on the Maven project, you don't have to give it any additional information. If it's using the Graal as the JVM, it's going to be able to use the native runtime image download to be able to do that. And if you're looking for that basic steps, I think we did talk about that a little bit in our first show. But you're basically downloading the GraalVM from the Graal website and then installing the native image plugin. So that's kind of the prerequisites for everything that we're going to go through. The rest of it is just going to be Maven and Java development.
Oh, that is so cool.
So just to go through some of the configurations that I have in here. So we're going to be doing, if you provide an image name, it will actually let you name the binary. If you don't do this, which I'm going to have, this blank in some of the later examples, it'll just name it basically the name of this class. So if you don't provide a name, it'll pick a name for you and it'll be long. It'll be a little bit obnoxious, but it'll work. The other thing that I'm putting is the main class because it has to know the entry point. So when you run the executable, where is my entry point into the application? It's just like if you're creating a manifest for an executable jar, you're just pointing it to the class that's the entry point. So from there, it is pretty much just regular Java development. I do have some properties up here to say which version. I am using Java 11 and the 20.3.1 version of the GraalVM, which has both the Java 8 and Java 11 version. We're going to be using the Java 11 version.
Nice.
And I also have the Maven compiler plugin on here at 3.8. You do need to have your Maven compiler plugin since it's one of the newer VMs. I do have these on here. We're not going to be using this in this example. I'll get into what these are for later. But the plugin is really going to be what's going to do my work. And I've got my dependencies. So we've seen the code. One thing I'm not going to do tonight is I'm not going to run the build at all for you folks, because if we were to run these Graal builds all episode, we would run out of time because they do take minutes to run.
So rather
than you guys listening to my fan burn juice and waste time trying to talk while these compiles are running. I will show you my configuration that I'm running in Eclipse to fire on these. And maybe we'll run one just for, just to give some context to things. Here's our runtime image. And as you can see, I got no cards up my sleeve. It's just a regular clean install. And my JVM is pointing to the GraalVM that I have installed with the native image plugin. That's it.
Nice.
All right. So what happens when I run this? So what I did instead of making everyone wait for it is if I run this just by itself, it actually works. But what happens is you don't actually get a native standalone image. You're going to see here that there's this warning. It says runtime image and it is in fallback image. So that requires a JDK for execution. And what this means is since it couldn't actually compile my code and it didn't really tell me why in here. We'll get to that. It's going to say, yeah, I'll run your code and give you a binary. But if you're going to run this, you need the jar and you need the JDK installed on the computer that this is going to go on. So you kind of, yeah, I gave you something, but not really useful if you're going to drop it on a Raspberry Pi or you're going to just give it to somebody to run in isolation. So what we need to do is it actually tells us what we need to do is we need to add the no fallback option here. And what that's going to do is this is going to say, hey, you're going to do a native standalone image or bust. So if it can't do the native image, it's going to fail the build. Now there still can be things where the build succeeds and there's a runtime failure. But if there's anything Graal is doing for you at build time and it sees that it's missing something or that it can't get to the next step, the no fallback is basically not going to fall back to that JVM based image. And one of the interesting things you'll see, so I have some of the images and I've just moved them out. If you run one with the JVM required, so this is what happens if you drop it. So this has a JVM, obviously, but if you drop it without the jar in the same folder, so it's outside of target, notice. If I run this, it actually complains that it can't find the class. So, I mean, you have this very dependent image. It does nothing for you really in what we're trying to accomplish today. So if you want to build a standalone image, no fallback is an option that you definitely want to specify as a build argument. So if I build with the no fallback option, it's forced to create that standalone image, which I can just drop anywhere and run. But what happens now is you get to find out, well, why did we fall back? So what I end up with is here, I get this error. This is on compilation. And what it's telling me is it discovered unresolved type during parsing. So it's looking in this impl class for the static logging binder, and it's mentioning something in the SLF4J log factory. So there's no point of entry for this method. And basically what that means is I don't actually have any logging configuration set up for SLF4J to do anything in this project. And when you run this as a Java executable, so let's do that real quick. If I just run the Java, again, this isn't Graal, but this is me just running the Java version. Let's see, I have that somewhere. Let's just fire it up here. Run, where is my run? Run as, I don't want the coverage. There we go. Run as Java application. It just gives me this error message. Oh no, actually the Java one works because I think there's some defaults that are provided that you don't get when you're a standalone. But if I run this as a Graal image, it's missing that implementation method. So one thing I can do is, let's say for this application, this is a production version. I don't actually want the logging. I just want the thing to run and print that finished output. So I want to be lazy. essentially, which is sometimes what you want to do when you're dealing with these native images. Sometimes the logging is really, hey, this is just a tool. It's for debugging. I don't really care. One thing I can do to get past that is to use an option called the incomplete class path. Because basically what this is doing is it's complaining that it can't find this implementation method. There's this entry into this implementation on the class path because of it's using reflection, and it can't deterministically figure out which logging implementation I'm going to use. And that's the problem. But with the incomplete class path, it allows me to compile this. So if I save this and run this, I'm going to get a binary that passes. And when I run it, it's very similar to a logging application running on a JVM when I haven't specified a implementation. So if I run this, we see this common error message that we see very frequently in tests where, hey, we just didn't bind, or you're going to use the no op, and it all just works. So I get my finished method. I don't get any logging except the logger telling me that it couldn't find a logger implementation, but I got to a standalone image. And you can see that I move this out of the target directory. Even if I move this on a computer that doesn't have a JVM, this still works. It does not require Java to run. So we got completely native in this execution with one of the libraries. So those are kind of the first things to try. If you have a simple application, maybe it has a logger, you just want to get it to binary and you want to skip some of that reflection and logging. This is one of the easiest ways to work around some of those limitations. All right. So that actually takes me through the first example, which again is a simple one, but there's a lot that you can get done with that, just that ignore class path execution. The next one's a little bit more involved and a little bit more interesting. So if I'm using a library that maybe uses JNI, for example, that is something that I might be interested in running natively. I'm already using JNI, so it's like, hey, why not take it the rest of the way?
Dude, all the way, JNI everything.
Completely native with it. And one of those libraries that I find interesting is Opencv, which is Open Computer Vision. Now, there's some folks out there that have built Java bindings to Opencv. So there's a, let's see, do I have it out here? Yeah, Open PNP is the fork, and it has basically, so Open CV it's written in C++. So you have to build a JNI interface to code in Java with it. So these folks have done that, and they've actually released a jar that has all the JNI configs. So I'm just writing Java and I can do computer vision, which is great. But if I want to do that in Graal, there's some things that happen. And you know, it's like, oh man, you're doing JNI. That sounds really complex. Does that even work with Graal? The answer is yes, it does. And it works just fine. But if I take this project where, you know, I'm using this method here to load my shared libraries, and we're on Linux, so it's a shared library, an SO file. You know, here are some of my JNI bindings where I've got an MAT. So that's basically a matrix. In Opencv. So I print the version here. I create a matrix. I'm going to print that I have the matrix, and this is basically just going to give me the hash. Hey, I have an object. Whoop-de-doo. We'll set some rows. We'll set some columns to a certain value, and then we print the matrix out. So simple things, but these are methods that are reaching into the native code and calling that code through JNI. So if I compile this, and again, I'm just using my same, I'm starting with no fallback, right? I'm pointing, let me get this out of the way. I'm pointing to my main method, right? I've included my dependency, which is the latest version of Opencv, and this is the jar. And within this jar are all the native libraries. So the SO file, the shared library is packaged with the jar file. So I don't need to download anything to use this. So it's all there. And if I build this, again, just compiler, plugin, same versions of everything else. If I build this, it actually builds. So I get my I get my image. So if I run this though, so this is, and again, this is an example of what it looks like when you don't specify the image name. So it's a little bit ugly, but that's fine. So this is the first version that we have in here. If I run it, I get an error. So, okay, I'm looking at the stack trace, class initialization. It's in the loader, right? So this is the loader that's supposed to load the JNI. So the natural thing is to look through all the Graal material for, okay, well, what do I need to do for JNI? Do I have all the settings? It's actually far simpler than that in order to get this library to work. What this is actually blowing up on, if I go into the code, it's blowing up because it can't find the shared library. So if we go to this Opencv local loader on line 339, and I love using GitHub just to find files. It's so fun.
And also this is just so everybody knows, this is the pro tip is going to the source of the libraries that you need to use to try to figure out what's going on.
Yes, it should not be scary.
Yeah, if you manage to get over that fear, oh my gosh, you open the pathway to like a lot of like goodness.
Yes.
Both personally and in your time and professionally too. So
yep. So line 339 is the Git instance that's failing, but it's basically in the load locally. So if I go back to my code, 339 is here. So it's the holder instance. So I got to get through the static initializer for that. So my constructor runs. It's somewhere in this constructor is failing, but it's not able to instantiate the shared object load. If I go into the extract, so here's my system load. This is where it would basically take this as the name and the path to it, and it would load it. It's blowing up. So one thing to know about Graal is even though it goes through all of the compiled Java classes in order to figure out what it needs to pull into that native image, one thing it doesn't do, unless you ask it to, is get resources.
So this is part of the resource, like the shared libraries are packaged in the jar.
Not pulled over by Graal.
Yeah.
You gotta tell it to pull those static resources over so that it can use them. So in order to do that, there's actually a couple different ways that you can do it. So if we go into, let's see, I think I have a link for this. Yeah. So there's actually a command line that you can use, and it's called H, which is kind of the non-standard options, -H resources, include resources. And what that allows you to do is you can provide a regex that will instruct Graal what paths you want to pull resources from. And this applies to the dependencies on the class path too, not just the project that you're building. So for Opencv, I can specify something that I know is going to pick up all of the standard libraries in my build arguments. So if I provide this option here, -A include resources, and I'm just going to wildcard the path, anything with a .so, what that's going to do, and this might be a little small for folks to read, is it's going to go in, and here's my Linux 64-bit SO library. It's going to pull that into the native image for me. So when I build this, and I'm not going to build it because it takes a bit, but I will show you the result of it. So this is library meta. Or no, this is with SO. So this is with the SO resource. If I run this, I get my matrix. So all it was, that error message was basically just telling me I didn't have the shared library built into the binary. Now I have it, and it works.
And this matrix was created on the shared library C++ side of things.
That's right, and bound through Java, but now we're all back native again. So it's 100% native. I can drop this in. You've got Opencv running on your Raspberry Pi, which you can do, but hey, this is probably much more efficient.
Oh gosh, yeah. One of the big things is doing JNI calls has always been like a bridge to crossover. So if you ever had to make it, it was extremely expensive to do it. Like having it all in native, oh, nice.
Very fun stuff. But it gets better because for this, I mean, look what I had to do here. I had to reach into the jar. I had to look around, figure out where the SOs, I had to read a stack trace. The library developers actually have a way where I wouldn't have to do this. And this jar could just work out of the box without having to do anything. So what Graal provides library developers with is another meta-inf folder called native image, where you can put configuration related to that library's instructions. So when you're pulling that library in on the class path, it knows what needs to happen. So this is an example of, here, let me find it. Here. So this is an example of some things that you can put in. You can put in a properties file. I've actually used the JSON version, but if you put configuration under this meta-inf native image folder within the dependent libraries themselves, you can actually take the configuration from the library developer side and it just works when I use it. I wouldn't have to apply that. So a couple of the things that you can create specifically for this one related to resources is a resource config. So resource config JSON is one of the accepted file names that you can put in that folder. And the way I can do this is if I pull down Opencv's library from Git, and in the source main resources directory, I just create this meta-inf native image, and I put in resource config JSON, and I just put my pattern right in here.
Yeah.
So basically anyone that downloads this jar file is going to get this instruction when they run the Opencv as a dependency. So if I build this, and I don't need Graal to build this, this is just a file that's included in the jar file. So I don't, as an Opencv developer, I don't have to, now I have to go out and get a Graal server to build with. I'm just building this into the jar, and this file now exists in the jar file that I'm shipping.
Mm-hmm.
Now, when I go to build it, so what I did here is I just kind of updated the version to 4.3.04. So I cut my own personal version of Opencv with this change in it. And then if I go into my Opencv code in my personal project, so here, I can actually remove this, right? So I don't need this anymore because it's going to come from the dependent library. So if I update this to 4, so that's my personally cut version.
Mm-hmm.
I still have the no fallback. It's going to read that resource config from the dependency rather than needing to put it in my own project's build arc.
So for library developers, this makes it extremely easy to make GraalVM compatible jars.
Yes. So now what I have is I have a separate image. So and then this is the library metadata version of it. Still works. Just fine.
Nice.
Except I didn't have to worry about any of the implementation details coming from Opencv in my project. It just worked right out of the box. So, if you're a developer looking to try to get involved in an open source project, this is a great contribution to give to a library. If you've started working with Graal and you're sick of trying to figure out all these things, go down or upstream to these libraries and offer contributions into those meta-inf folders and say, hey, these are the configuration files that worked for me locally or for my project. Why don't we try integrating this into the library so nobody has to go through that pain again? Great way to get involved.
And this sounds like a great pull request to offer to Opencv.
Yeah, then you could be a committer on more stuff, right?
Yeah.
That's just what I need.
There's just too much time on the day, right?
Yeah, absolutely. But yeah, this makes a lot of people's lives easier. So it's a great way to contribute and make native images easier for the rest of the world. So that's my Opencv example. So now we know four different ways of doing these configurations. And there's a lot of these configurations that you can put into those meta-inf folders. So there's reflection configurations that you can put in there. Let's actually go back because there's actually a plugin that'll generate, they have this agent that you can point to your jar file and it'll actually generate these files formatted for you. I didn't do that for these because I just didn't have time to get into running the agent. But if you're trying to figure out, hey, what is the format for these supposed to look like, or maybe give me some suggestions of something to start with, this agent library running against your jar will generate these configurations to a specific directory, and then you can just put it in the meta-inf. But you can get the JNI configs if within your library you're actually creating the JNI bindings, not if you're doing JNI, because obviously it worked for me without any JNI configs. Reflection, proxies, and then the resources, which we ended up using. So that is kind of the library development angle to that.
That's nice.
And that brings me to my last example, which involves integrating into the Apache HTTP components as a client, which is another very common use case. If you're building tools for your developers, you use a lot of stuff as API driven. Why not just hand off a little executable to your team members and say, hey, yeah, just click this and pass some parameters to it, and it'll do all those crazy scripting things that you need to do for your job, automate some things away for them. So let's take a look at the code there. But this one's going to get a little bit more involved because there's a couple of different routes that we got to go to. But we're going to start with just a very simple bit of code. We're just going to call a GET request to the Java Pubhouse website. In case you don't know where our website is, this is where our website is. Go visit us. We're going to print the content, then we're just going to print the status code and the reason phrase. So it's going to dump a bunch of HTML and JavaScript on the screen, and then it's going to print the status. So with the JVM, this works just fine. Right off the bat, we can get this running. But if we're going to run it in Graal, there's a couple of different things we're going to run into as we're going through this project. So the very first thing is if I build this, it actually builds. So there, you don't get any errors in it right off the bat. But actually, let's run it real quick. We'll build one of them while we go, because I actually want to check that, because I didn't actually copy any error messages, because I think they're all runtime error messages. But let's kick this off. And let's actually look at the POM file while that's running. So this one, again, we're starting with our usual, let me put it off to the side. And we'll put this down here. You guys can hear my fan running soon. I just started with the no fallback option. We're pointing to our HTTP main, which is our entry. You'll see that as far as, so yeah, still Java 11, Graal 20.3.1. We've got our dependencies, our Apache HTTP components client, so 4.513. And that's it, just because that's the only dependency I'm using. Now I do get some transitive things with that. I've got my Apache Commons, my log4j coming on the class path. I get codecs from this. So there's a few transitive dependencies that are coming with the HTTP components, but for the most part, it's still pretty light dependency wise. Now it looks like we've got several different phases this runs through, so it's still not completely built yet. And I can't tell you what exactly every single one of these phases do, but it does take a while. I'm actually kind of curious what these gigabytes is like. This is not the size. This is not the size of the binary, so I'm not sure exactly what this is measuring.
Oh, maybe that's the whole world before it decides to like trim it down.
Before it trims it down and optimizes, maybe.
Yeah.
All right, so this is successful. So you got to see one run. This build took a minute, and it's only like 10 lines of code. So if you have a big project, got to be patient if you're going to be doing it with Graal. But let's take a look. Let's actually run this and see what happens. This is Graal HTTP. We got to go in our target directory. So you see, I've got my executable that we just built live in real time, and it's going to work. No, it's not.
Oh, the logging.
So we're back to logging again. So you're constantly fighting log implementations in Graal because of all the reflection, all the kind of magic before them. But we have some previous experience doing this. The problem is this error message. It's a little different, right? So it's not that it's can't find the entry to the class. It's actually no class definition found error. So it's as if the class is not there. And this is a very common thing you see in Graal when something is kind of expected to be there through reflection. Because if you look at my code, you don't see any reference to logging statements in my code. All of the logging statements is being included because of the HTTP components client. So it's all behind the scenes stuff. And I don't want to look through all of the HTTP client code to try to figure it out. But one thing I can do is if I know something is not found and it's because I suspect it's reflection, I can create a configuration for Graal to go ahead and instantiate those objects that would normally be instantiated through reflection in the project. And just to build on what we were showing off before with the library developers, I can do that in a meta-inf class. So again, my resources directory, meta-inf native image. If I create a reflect config, and I just named this with a BA key extension so that it didn't get picked up so we could actually see the error. Let me refactor and rename this so that it'll work. So reflect config.json is the name of the file. And if I look in this, one of the things it was saying it couldn't find was the log factory. Now, I may have to build and run several times, and it'll pick up a new file each time. I'm going to save us some of that frustration. The two that you'll see is the log factory and the simple log, because and basically I'm instantiating this because I'm saying, you know what, I do want a log implementation because I want to see the logs. But let's not get crazy. Let's just use one of the really basic ones. So I'm going to instantiate the logging factory again, because it would normally be built out via reflection, and the simple log here, so that it just creates those files for me and can convert them into a binary image so that it's already included in our binary. Now, thread and string are a little bit different and interesting. Those you wouldn't run into until later in the project. And we can maybe take a look at that. We'll see how we're doing on time later. And if we get there, I can definitely go into why I think string is on here. Because the error you hit, it's like, how do you not have a string? Right. But you see it when you look at how they're using it, you'll see there's some patterns where those will come up in certain classes. But let's move on. So if I were to build using just this reflection config, hopefully we get a little further, right? So let's bring up our command prompt. So we've got a couple in, so let's actually move out. I'll go back to the ones that I pre-built because I don't want to subject you guys to a minute of waiting between every single one. So that's what we built is the same one as initial, which is our starting point. So if I add the reflection, there's a with reflection binary that I created. So once we've added those 4 classes and we run it, we have another problem. So in this stack trace, it's now telling me, okay, the common log factory impl, we're seeing another class not found, log factory impl, create factory. And this is where things start to get really freaking hairy. Because let's say I wanted to go into this method, this log factory, create factory, and start asking the question, well, why is this blowing up? So let's do that. So I can go into, let's actually log factory impl here, right? Let's find out where is it blowing up, create factory. So am I in the right one? I might be in the wrong one. Oh, it's actually just log factory, create factory, not in the impl method.
Yeah.
Log factory here. And it's an abstract, so it's the one with the class loader here. And I start going through this code, which again, none of us should be afraid to do. But okay, we got reflection going on. My God, look at all of this stuff. Do I really want to go through and try to work around all of this code that's in here? I'm going to answer that. No, we don't want to do it. One thing that allows us to short circuit some of these cases where it's like, oh man, I'm now going to die a death by 1,000 cuts here because I'm going to end up going through and it's going to be reflection upon reflection upon reflection. Graal actually offers us a way just to simplify things, and it's called substitution. So I have this big hairy method. One thing I can do in my main class or in any class that's in the Graal project is I can actually take that implementation and substitute it for something simpler. So when you're compiling with Graal, when it gets that method, I can actually rip it out and put my own implementation in, which removes all the reflection and makes things extremely simple. So here I have an example of a substitution annotation. And I'll just paste these in here. So here's my log factory substitution. Let me get your head out of the way. So where I was going into a new factory, I can just say, hey, new log factory impl, done. Get rid of all the reflection. And now it's a very deterministic path through the code because I already know which one I want to use. I don't need all of this dynamicism in my code. I'm just going to use the regular log factory implementation. Forget class loaders, forget any of it. And this makes it easier. So what I need to do, the substitute method has the same signature as the one in the log factory class. So I define the same implementation or the same function here, interface.
Same signature.
Signature. Yep, that was the word I was looking for. And then I replace it with a new implementation. Then up here, I can name my class whatever I want, but it has to be final. So anytime I'm using this, it has to be final. And then I define a target class of, okay, what's the class that I'm going to replace? Now, if I were to build this again with just this method, we would actually run into another problem, which I created another substitution for here. And again, all I'm doing is I'm removing a lot of reflection that's through configuration, through properties file, which Graal is not going to be able to really look at and get into, and just replacing it with a simple, hey, let's just use the simple log here. Make life easy. I target this class, and this implementation substitutes the implementation found in the open source project. So I don't have to go submitting patches to these projects to make this work. I'm just substituting it for my project. And what enables me to use these annotations, and I said I would get back to this, is the SVM artifact in the Graal native image dependency. So I can add this dependency, and it's just a provided dependency because Graal, the VM is actually going to provide this code for me when I run the plugins and everything. But I do need to put this on my my class path in order to be able to pull the substitute and target class annotation. It's going to have the same version as the GraalVM I'm using, and I can stick provided in here so Graal knows it doesn't have to build this into the binary for me. It's just doing the substitutions and then building that code into a binary image for my output. So that's substitution. Can be very useful if you're just trying to be lazy and say, you know what, I don't want to solve the hard problem. Let's make the problem simpler.
Just return new implementation and that's it.
No reflection, just do this. So we're getting closer. I can tell you that. So I've got another binary image built out where we have our reflection in, and now we've used with substitution. So I have my with substitution binary here. So I'm going to run it one more time. Still blowing up. But to Java developers that have ever worked with TLS or SSL, call it what you will, some of these classes look fairly familiar.
Yeah.
And even if I were to use HTTP, as long as I'm using the Apache library, it's still going to go down this code path where it's going to try to, this is in the HTTP client builder. So whether I'm actually using a secure protocol or not, I'm hitting this code. So I could even go back and change the URI that we're using, and I still blow up on this. But this can be really confusing. But at the end of the day, it has to do with Graal being kind of minimalistic in what it's going to put in that native image. So these are all security-based libraries. And if we look at our Graal native image options, if I look for security, I actually have to tell it to enable the security services before all those things are included in my native image. So again, this thing compiles, it pushes out a binary, it just don't work.
But this is probably because the security footprint is probably big.
It's big. And you know what? Why don't we take a look at the image sizes when we're done? Let's hold that thought, because maybe that's exactly why it is. But all I need to do in order to get this is I just put in my enable all security services in here in my build arguments. And then I can build one more time. And then that one is my final.
Mm-hmm.
Boom.
Yay!
So I get a bunch of HTML, I get 200, and I'm able to do HTTP calls. Now, one of the interesting things that I discovered when I was going along trying to put this all together is there's other options in here that I thought I was going to have to use that I didn't have to use. Look at this, like enable HTTP, enable HTTPS, enable URL protocols. For whatever reason, and maybe this is a follow-on episode, I didn't have to enable any of these. Once I enabled the security services, I could use that.
Oh, it almost like you brought it over, or yeah.
So, so let's actually look into Freddie's hypothesis and see what the sizes look like. So let's see. So this is the initial. So this is 21. What is that?
About
21 megs.
2-H.
Yeah.
Like if you do ls-l, that's H.
Oh, let me make this bigger.
Yeah.
That's H. Okay.
Yeah. There you go.
I don't know. Oh, that helped you. Okay.
Yeah. Yeah.
Oh,
no.
Okay. Yeah. So 32 megs to 21 megs between our final from our beginning. So
yeah.
It actually got smaller with just the reflection one. So it went initially 21, and then it went down 7 megs. Then it went back up. And then when we finally added in security, so it's 11 megs worth about.
Oh, interesting. The reflection took out. Oh, because it probably took out smaller. All that path of.
Or wait, am I just not lining this up properly?
Yeah, make it bigger.
Let me make it bigger. It should be away from
or wider.
Bigger. I'm worried that people won't be able to see. What do we do? Terminal. There we go. We'll just Control plus. Yep. Is that a little better?
Yeah.
There we go. Let me move your head. Yeah. So here's the initial. Yeah. So it did go. It went down. Went from 21 to the start, the initial, to 14 when we added the reflection. Back up when we added the substitutions. And then when we added security, it added 11 more megs. So probably just an optimization, right? That they don't include security. If you're not
10 megs on. Yeah. Well, I guess 10 megs on embedded used to be a big thing, but I guess, if you still want to get the smallest possible footprint.
Yeah. Yeah. Not as much anymore. But yeah, now we have for TLS and all of those options, enable security is our bet. And also, I do want to call out credit where credit's due. So I was actually the substitution. I cheated a little bit and was able to go and find a Graal issue that had exactly this config. And now that we're here, I will let you know is just, kind of being curious about this thread and string thing. I did create the reflection without the thread and the string, just to see. It's like, do you really need those?
What is
this
it?
Seems weird. And you do get exceptions when you run it here. Let me see if I still have my last jar in where I was, or actually maybe we could build it without them, just for fun. We got a few minutes, right?
Yeah.
Let's just remove both of these
and see what happens.
And just see what happens. The string will fail first, if I remember correctly when I was doing this. So yeah, Graal HTTP. Yep. You want to save main. So we'll leave all the other stuff in here because you don't actually hit these until you do the substitution.
Mm-hmm.
So these all, and again, every single one of these with HTTP components compiled fine. So I never actually hit any errors at build time, but at runtime, all of these failures were happening. Once we run this, it'll give us the error for the string, and then we can go to the line in the source code and take a look.
And it's interesting because it's one of those things that you sort of pay the penalty once, right? Like you're trying to bring a project to native, and you find an issue, you sort of figure it out. What is it that I need to either substitute, reflect, or configure. And then after that, you run it again, you find another thing. But once you get this iteration going, and GraalVM helps you by saying you just have to add it to either my meta-inf or as part of your pump build, and then it's there. And then you essentially don't have to worry about it, as you keep working on your project. And the fun part about it is that even though it's a pain to do it once, the benefits, especially if you're talking about cloud containerization and size and performance, you can get faster Java than this.
Yeah, and it's funny because I'm going through and I'm saying, you know what, we're just going to simplify this and make it easy, and we could go through and try to fix every problem. What you'll see in open source projects, and this is kind of from the episode I did last week with Josh Juneau when I was going through some of the Quarkus Camel integrations, is even in the open source projects where they're building extensions for Quarkus, a lot of the times the library developers are taking the easy ways out. They're not trying to solve the hard problem. Is okay, how do I get all this reflection to work? It's like, let's make it simple. One example in Quarkus, if you're using Netty has some native bindings. Right. So if you want to use a native epoll, which is, it's something on the network stack that Netty can use. And there's a shared library that comes with Netty that Netty will use if it's there and configured to. For that implementation, they hit a very similar issue that we hit with Opencv. It's like, oh, well, just include the shared library, right? They use substitution to basically just flip that option to false every single time. So you never use the epoll and you just never go down that code path. You're compiling to native anyway. So, I mean, do I really need epoll? Well, maybe, but they decided that, for their maintainability and their own sanity is they don't want to have to, deal with Netty if they were to ever change that shared object library or anything in it. They just said, we're just going to force you down this path. And that's how Quarkus has their Netty implementation through Camel. So the Camel Netty component does not use the epoll shared object library. It just uses the Java specific one compiled to a binary.
Which is, it'll be interesting to see if there were significant performance differences. Once you start getting into native though, then I presume that they're, they should be very close.
Yeah, no, I'd be interested to see it. And if you're a library developer, you have to kind of make the trade-off for maintainability. What's going to allow us to keep evolving our stuff while they're evolving their stuff and not break. I mean, you have to think about all these things. So, maybe they just decided, hey, the trade-off is not worth it. We're just going to turn it off.
Do this. Yep.
And that's totally acceptable. If you do find, hey, man, you just killed performance by doing that. Maybe that's worth a pull request and looking into, hey, let's include that resource. There's ways in Quarkus to do that. But what's the cost? All right, so let's take a look. All right, so I have my native library. So let's run it. All right, here we go. No class def Java string. Can you believe that?
Oh my gosh.
But let's go back. Let's find out. So here's my log factory impl. So that's line 210. Let's see what's going on line 210.
It must be something.
Must be something crazy.
Yeah.
210. Here it is. Interesting. It actually has the fully qualified. I wonder if it has to do with the fully qualified name being here instead of it just being Java string.
Because it's a class. Yeah. So the Java line string bytecode is there, but the class which contains it's almost like the meta object that contains like the class definition. Oh, and they're separate. I did not know this.
There you go. And thread is a similar case. Thread, they're also, I did look into that. It's a thread.class, and then it's calling one of the methods off a class on thread.
I'll be interested to see, like, it's almost like a bytecode representation that is, the package name is Java line string, and there's probably bytecode that defines the class, and that's what's missing. Oh, that's fun.
Interesting stuff, right?
Yeah.
All the fun you get to run into if you want to start going down the binary path.
Yeah. No, again, remember, like, not for everyone, but if you happen to be on that use case, well, let's put it this way. I think the GraalVM, I think the Graal folks published a study or some benchmarks where they say, I think they save like 20% CPU time, like when you move to native from just a regular JVM.
Yeah, you know what? Why don't we include some of those benchmarks in the show notes? I don't remember enough of them off the top of my head to be able to cite benchmarks, and I don't want to mislead people. But yeah, I do recall there being several claims of better performance off of the GraalVM.
Oh no, they have it on well, they have it on their homepage. It says,
oh, there you go.
50x times faster for startup time. Finds 5x times smaller for memory footprint.
Okay.
So
I believe it on the startup time. I believe it. I think, the more interesting things, if you have longer running processes where it's, something where, hey, I compiled it into a native image and it's running for a while. Hey, I don't have a JIT. I don't have, some of the optimizations. Now there is actually profile optimizations in Graal, but that's for another day, where you can actually run your code and it will try to pick up optimizations for you.
Yeah, so it is interesting, like, especially, again, remember, if you're in an environment where startup time is important, because let's say that you're cycling, like, you have sort of like scale up or scale down policy in your cloud world, and getting these things in rotation, with the least amount of downtime is important to you.
Yep.
Then startup time becomes important, right? Like memory footprint, again, same deal when you're dealing with cloud and you have sort of like like you're paying for the type of machine that you're getting, and you're getting a 2 GB machine, a 4 GB machine, and you want to keep that footprint small for your base jar that you need to load in memory. These things, again, or embedded, these things are best bang for the buck.
Yep.
So,
yeah, as much as disk is cheap, memory's still not. I wouldn't call it cheap yet.
Cheapish. Yeah, but not cheap.
But not cheap. It's still very, very measurable. Especially, JVM apps do have a reputation for their memory footprint, because you have the overhead of having the JVM running. Some of the binary stuff will remove some of those things.
No, and it's funny because I was actually looking at some stuff today on iron monitoring, and one of our panels said the average memory usage of one of our VMs was 2 gigs. And we're like looking at it, and then like well, we set it up to be 4 gigs. So what's going on? And then of course, what was happening, it was like the actual like base profile was like half a gig, but then you get, such a lazy garbage collectors where you go in and run up to get all the way to 4, does a big, like a full GC, and then goes back all the way back down. So the average is 2.
but you're doing all those stop the world collections and slowing things down and
so yeah, yeah, it was one of those days. But this is fun. I love it. It's one of those, and it's one of the things that, because there's interest, right? Like GraalVM is going places. It's backed by like the big guys like Oracle. I think Twitter is in the middle of it. I
think Red Hat's involved with their own things, and it's big.
Or IBM, I guess. Right?
Also.
Yeah. Well, I guess technically it's all IBM now, right?
I mean, IBM's very heavily invested in a number of frameworks. So Red Hat. What Red Hat's doing is IBM, obviously, but Quarkus, which has a lot of push with IBM behind it. IBM's just highly invested in Java. So, I mean, it's definitely in their interest to be
and we know stuff. We know that Spring, the big framework, it's also working on being compatible. So there might be work that we still need to find these little quirks as we go through. But it's gonna get to a point where most jars will have that sort of meta-inf for them to be essentially native image compatible.
Yep. And
when that happens, it's gonna be even easier to create native images. And gosh, I can't wait for the day, because those are shiny toys. But if you want to get a head start, you know how to do it now. So
that's right, and you know how to share it too. So I mean, definitely consider contributing to libraries that are on your list, because
they'll love it.
It's not pain-free, but in the end it could be worth it, and you could save people a lot of time.
Yep. All right. No, that was an amazing tour de force through the innards of GraalVM, besides the Hello World, which we know and love, but this is actually more practical than that. So that's fun. Thanks, Bob.
All right. Yeah.
All right.
My pleasure.
And with that, I think we are done with this episode of Java Podcast. Happy programming, everyone.
Bye, everyone.
Take care.